Hi there. For this video, we'll be discussing how to simplify complex rational expressions. So we first recall that in fractions, if we have 1 plus 1 over 2 over 1 minus 1 over 2. Now our goal in here is to simplify this fraction so that the outcome is simply in the form a over b. So basically we want to eliminate this denominators out here. So recall that to do that, what we do is we multiply the LCM of the denominators present. In this case, if we write 1 as 1 over 1 and 1 out here as 1 over 1, then the LCM simply is of these denominators is 2. So multiplying that, multiply 2 over 2 out here, and we are left with 2 plus 2 over 2 all over 2 minus 2 over 2, wherein 2 over 2 is simply 1. Simplifying further, this becomes 3 over 1 or 3. So we will apply this same concept in rational expressions. Let's have this first example. Let's have 1 plus 1 over x all over 2 minus 1 over x. So what would we multiply out here? Since we have a denominator of x out here, and we know that since this is just a whole number, its denominator is 1, then what we multiply out here is x over x. By the way, we multiply x over x since this one is just equal to 1. So it doesn't change the value of the original complex rational expression. So multiplying x over x will obtain x plus x over x, since we distribute this one to this and to this, and we do the same for this one. So we'll have at the denominator 2x minus x over x. X over x is simply equal to 1. So we'll have x plus 1 over 2x minus 1. That is the answer, since these are already in linear factor, so we can't really cancel anything from the numerator and the denominator, and we have simplified the complex rational expression. Let's have this second example. Let's have 1 over a plus 1 over b all over 1 over c plus 1 over d. So what do we multiply on this one? Note that since a, b, c, and d doesn't have any common factors, their LCM is simply a times b times c and times d over a times b times c times d. So that is what we'll multiply out here. Upon multiplication, so we distribute this one out here, and this one out here, this one out here, and this one out here. We'll obtain a, b, c, d over a plus a, b, c, d over b all over a, b, c, d over c plus a, b, c, d over d. And from here, we just simplify. We have a common factor of a out here, so we cancel that one out. We have a common factor of b common factor of C and common factor of D. So this one simplifies into BCD plus ACD all over ABD plus ABC. And this could be our final answer. But if you want, you can simplify the common factors out here. In the numerator, we have common factor of C, CD. And in the denominator, we have a common factor of AB. So to just write it much better, we can write this one as CD times B plus A or A plus B all over AB times D plus C or C plus D. And that is the answer for this one. Let's have this third example. Let's have 1 over x minus 1 over x squared all over 1 over x cubed minus 1 over x raised to 4. For this one, note that we can write this one as 1 over x minus 1 over x times x all over 1 over x times x times x minus 1 over x times x times x times x. So given this, we can see that their LCM or their least common multiple is this one. Since upon multiplying x times x times x times x or x raised to 4, we'll be able to cancel this one, and this one. So we'll do that. We'll multiply x raised to 4 over x raised to 4. We obtain x raised to 4 over x, or simply x cubed, minus x raised to 4 over x squared, or simply x squared, all over x raised to 4 over x cubed, or x, and x raised to 4 over x raised to 4 is 1. Then from here, observe that in the numerator, we have a common factor of x squared, since x cubed can be written as x squared times x raised to 1 by loss of exponents. So this one, we can factor out x squared, we'll have x squared times x raised to 1, or simply x minus 1 all over x minus 1. And then we can cancel the x minus 1 out here, leaving us with our final answer, which is x squared. Let's have this fourth example. Let's have 1 plus a plus 1 over a minus 2 over 2 minus 1 over a. Now for this one, note that since a minus 2 and a doesn't have any common factors, what we do is we multiply a times a minus 2 in the numerator and a times a minus 2 in the denominator. So we distribute this one out here, this one out here, and this one out. So when doing that, we'll obtain a times a minus 2 plus a plus 1 times a minus 2 over a minus 2 all over 2 times a minus 2 minus a times a minus 2 all over a. Then we can cancel out the a minus 2 out here and the a's out here. So let's remove this one, or let's just resize this one. So we'll obtain in the numerator a times a minus 2 plus a plus 1 times a all over 2 times a minus 2 minus a minus 2. Now you could simplify this immediately, but to avoid possible further complications later, what we could do is we could do some algebraic manipulations. So first, since we have a common factor of a in the numerator, we can factor that one out. And since we have a common factor of a minus 2 in the denominator, we can also factor that one out. So we will have a times, what's left inside is a minus 2 plus a plus 1 over, we can factor out a minus 2. What's left inside is 2a minus 1. So let's remove this one. And from here, we simplify this part out here. So we'll obtain a times 2a minus 1 over a minus 2 times 2a minus 1. Since we have a common factor of 2a minus 1, we can cancel that one out. And the final answer is a over a minus 2. So that is a great tip that you can use in here. Before simplifying this, because when we simplify this one, we'll obtain a quadratic expression, which we still need to factor out later to simplify this fraction. But from here, if you can do some algebraic manipulation and factor out common factors, so that upon solving, you'll immediately see that there is a factor out here, like this one, 2a minus 1 over 2a minus 1, to be cancelled. Let's have this one final example. Let's have 4 plus 1 over m squared minus m over 2m minus 1 over m minus 1. Now note here that even though it might seem that m squared minus m and m minus 1 doesn't have a common factor, we can actually apply some factoring tricks out here. Since m squared minus m can be written as m times m minus m, so there is a common factor of m, we can factor that one out. So we'll have m times m minus 1. So they have a common factor of m minus 1. So what we need to multiply in this rational expression is simply m squared minus m, or m times m minus 1, since that would cancel out this m minus 1 denominator as well. So doing that, we multiply m times m minus 1 over m times m minus 1. The outcome for this one, let's resize this one. The outcome is 4m times m minus 1 plus, we know that m times m minus 1 is m squared minus m, so This one will simply be 1 all over the denominator. We'll have, when we distribute this one, m minus 1 would cancel, so we are left with 2m minus 1 times m. Now, from here, what I'll do is, I wouldn't factor, or I wouldn't multiply this denominator immediately, since I might be able to cancel something from it. But since we can't really factor anything from the numerator, that's what I would simplify. So simplifying the numerator, we'll multiply this 4m out here. So the numerator will have 4m squared minus 4 minus 4m plus 1 over 2m minus 1 times m. Now from here, what can you observe in this numerator? Well, observe that this one is actually a perfect square trinomial. Indeed, the first term is a square, since we can write this one as 2 squared times m squared, and the the last term is 1, or simply 1 squared. And you can verify that when you multiply this 2 times 2, the outcome is this one. So by perfect square trinomial, we know that 4m squared minus 4m plus 1 is equal to 2m minus 1 squared. So we can verify that one. So this one will be equal to 2m minus 1 squared, or simply 2m minus 1 times 2m minus 1 all over 2m minus 1 times m. Observe here that we can cancel out a 2m minus 1 factor, so we are left with 2m minus 1 over m. And that is the final answer. So as you can see, we can still apply the concepts on factoring polynomials in rational expressions. So as an exercise, you can work on this example: 2 over a plus 2 minus 3 over a plus 3 all over 6 over a squared plus 5a plus 6. As a hint, you will use the factoring method on factoring general quadratic trinomials. So that's it for this video. I hope you learned something from this, and feel free to comment down below your solutions, your recommendations, and your answers to this exercise and in this video in general. So that's it, and that is all for this video.